So guys, in keeping with me being an evil math teacher, you all should be able to do this. You have to. You have to. Can I solve directly for y? Can I put those terms together? No, right? Because they're not like terms. Do I have a variable expression that has a power other than 1 on it? Yeah. Anytime that happens, I want to get it equal to 0 and then
So?
how? Do what to this?
Factor.
Factor it, yeah. Right? You guys, so if that wasn't there, that's silly easy, correct?
Mm-hmm.
I just divide by -9, y equals 0. Kick ass. Ah, shit. So I can't put those together. So I can't get all my y's together and then divide. I can't, because they're not like terms, right? You guys see what I'm saying? So every single one of these has powers higher than 1. If it was just that here, if that was the problem, wouldn't I add 2 divided by -1? And I'd be done. That kicks ass. You guys are kind of with me. Because all my x's are together in one term. Can I get all my x's together now in one term? Shit. So whenever the variable you're solving for has powers higher than 1 or different than 1, let me say it more generally, you have to get it equal to 0 and try to factor it. That's the way around that. So what's the first step in factoring this? Is it a cubes? Is that a cubes?
It's a cube.
That's a cubed. Is this a cubes?
No.
Hell no. Can you break y up into 3 parts nicely?
No.
No. What do you always try first when you're trying to factor? Greatest common factor. So what comes out?
Y.
A y. Kick ass. Right? You guys with me? Is that all right? Who asked that question again? I'm sorry. Does that make sense? Whoever asked that question? Okay. Anonymous person. All right, so take a y out and then see what you're left with. I'll tell you, it'll factor again. Are you guys are all with me? So, I mean, all right, so if I take a y out, what am I left with?
4y squared minus 9.
Yeah, just take a y out of each piece, right? What's this? What's this? Can you factor that?
Perfect square.
Perfect squares, the difference of squares, yeah. You guys are all with me? No, yes.
And so two of those solutions are gonna be plus and a minus.
Yes, exactly.
And the other one.
Let's do a problem like that, okay. What do you got, Jeff? Okay.
So you can factor out m squared.
Yeah, I can take out m squared. Poor little camera. Okay. Take out m squared. What's left?
M squared minus 25.
Yeah, just lose 2 m's from each term.
And you've got another perfect square.
Yeah, so then I get m squared times, somebody else tell me now. How do I factor this? Say again, sorry.
I said plus 5 minus 5. Minus
Be a lot more
5.
specific.
I'll do, okay. I don't know.
What goes here?
M
Yeah, good, yeah.
minus 5 and plus 5.
There you go. Okay. I knew what you meant, but I need to like hear fully. How many numbers are multiplying right here? Yeah, 1, 2, 3. Yes? You can see that. And in order for this to equal 0, at least one of these numbers has to be 0. So either m squared is 0, or m minus 5 is 0, or m plus 5 is 0. Cool. That's the power of setting it equal to 0 and factoring it, because then you know at least one of those has to be 0. And now you got simple little things. M equals 0, m equals add 5, m equals subtract 5. 3 answers. And that matches with the fundamental theorem of algebra, which we're going to talk more explicitly about later, but we already saw it. Do you see how many zeros are there? How many times does 0 show up as an answer? twice, right? So there's two of these and one. So 1, 2, 3, 4. 4 solutions. Just two of them happen to be the same. Okay, maybe. Okay, right? So we know this, but I think maybe when you get to a new section, you think everything's new, and I've said this before. No, some of it's going to be old stuff, right? The stuff we haven't talked directly about yet, I don't think, is down here and up here. These things. So this is what I would expect to give you a lot of trouble. This one you might have just thought, oh, it's new. No, it's old. It's the same old thing. Okay, maybe. Yes?
Can you, well, I know you haven't gone over, but 11.
All right, let's go over it. Okay. I'll move you. Okay, stay. Let's see. All right, so I'm going to start off with a way too nice of a problem here. Let's see. Okay. So you're all like, yeah, Jeff. Sure. If only 11 was that. Hopefully right now you guys are all thinking that. If I give you this problem, I need you to be able to just, eat this problem. What do I do? Can I get all my x's together? So what do I do? It's already equal to 0, correct? So then I factor it. What do I get? Two numbers that?
-2, -5.
Yeah, -2, -5. Two numbers that multiply 10 add to be -7. You guys with me?
Yeah.
All right. So x equals 2, x equals 5. Okay, that's an easy problem. Yay, Jeff. So let me make it look more like that one. Let's say I've got x to the, what do you got, Jeff? Sure. X to the 1/2 minus 7x to the 1/4 plus 10 equals 0. So there's a key thing that's true here. Why did we put an x and an x there? Because it's squared, so I broke it up in half. Makes sense, right? Notice how the middle term has an x in it. So that it makes sense that actually if I break the first term up in half, it becomes what the middle term kind of looks like. Do you guys see that? Anytime the middle dude is half of the first dude, it will work the same way. Okay, maybe. So what does that mean? Well, what do you get when you cut this in half? Same thing I did here. All you did was cut it in half, correct?
Yeah.
What's half of a half? 1/4. Does that match the middle term?
Yes.
Yes, so when you do the FOIL business, I will get x to the 1/4. If that said x to the 5/4, this thing is screwed. It doesn't work. The middle one's not half the first one. It's not going to work. Okay, maybe. So we're just expanding what the hell we did here. Why does this work? Because the first dude is twice the middle. The middle is half the first, right? So when you cut this in half, it matches. So as long as this power is half of that power, you could do the same first step. Cut this guy in half, bam, bam. Of course, we already know the numbers that work, right? The numbers don't give a shit, by the way. But aren't they the same numbers that work?
Yeah.
So then I get x to the 1/4 equals 2, or x to the 1/4 equals 5. Now the trade-off is, you ain't done yet. You don't have x by itself yet. Let me stop for a minute. Are you guys at all with me? Okay, we desperately have to know how to do this. This should be like, really, Jeff? Really? Just that? Sweet. That should be what comes out of your mouth, or at least in your head when you're taking a test. If they give you that problem, you're like, oh, thank you. Are you guys kind of with it? If that's not true, come see me. At this point in the class, you have to just love this kind of problem, right? Or at least be really cool with it. This problem uses the exact same reasoning. It just looks worse, right? 1/2 and 1/4 are way worse than frickin' 2 and 1, I agree. But you see, they have the same relationship, don't they?
Yeah.
So as long as the middle term has a power that's half the first term, this will work. Now, how the shit do I solve for x? What's a 1/4 power? Also known as, it's trying to be a 4, by the way.
The fourth root?
4th root. How do I kill a 4th root?
Fourth power.
Raise it to the 4th power. Are you guys with me? And look what happens when I raise this to the 4th power. What happens with these?
They cancel.
Cancel. So then I get x equals 2 to the 4th, which is 16. Or 5 to the 4th. Oh shit. 5 cubed is 125. Times 5 is 625. Okay. You can just throw that in your old calculator if you want to. Are you guys kind of with me?
Yeah.
The reason this problem is nice is because when I cut it in half, x is already solved. This one, when I cut it in half, shit, I don't know what x is yet. I have one more step than normal. So let me ask you this. These are called quadratic in form. Oh shit. Quadratic in form just means the middle power is half of the first power. So tell me this, is this quadratic in form? What, Jeff? I don't know yet. Hold on.
Yeah, 10 root.
Yeah, what's got to go here? Let me change my problem up a little bit. Yeah, if this was a 5th power. That's quadratic in form, correct?
Yeah, 10 or 12.
What? That? Oh.
Thank you.
You're welcome. Can you make a problem that works, Jeff? Yes, I can.
Yes, that is quadratic in form.
Totally. Cool. If I made that a 4, we don't know how to solve that yet. Okay. You guys kind of with me? Does that make sense? Yes? 2/6. Yeah. We stopped right before 2/6. We stopped at 3/5 before the test.
Yes.
So if I want to finish this, finish it. Well, we go here and here. Yeah, cut it in half, right? So then I make 10 when I put them together. And that matches with the middle term, correct? That's why it works. That's why the middle dude's got to be half the first dude, because the first step we do is cut that guy in half. What numbers work? Did I make a problem that works? Yay, Jeff. What's the next step? What do I do? I got 2 numbers here, yes? One of them's got to be, at least one of them's got to be 0. So either this guy's 0 or this guy's 0. So now just start to solve. How do I solve this? Add 2. And then?
5th root.
5th root. Kick ass. So x equals the 5th root of 2, and you can put that in your calculator, get an approximation. Are you with me? And then the same thing over there, yeah.
In the test, do you want us to put in the calculator and get an approximation, or just leave it like that?
Depends on what I say.
Yeah.
If I say exact answer, this is the exact answer. I know us humans, we're all humans here, we think exact means a bunch of decimals, but that can never be exact if it goes forever, because I can never write all the frickin' decimals. That's exact. If I throw it in the calculator, I can get an approximation. If I don't say, you can just stop here.
So approximation, you just mean
Throw in the calculator, write down a few decimals, right? Round it to something.
round it.
Okay, you with me? What is the 5th root of 2? How do you do the 5th root of
32.
2 in your calculator?
32.
No, it's the 5th power of 2.
Oh,
It's
So you go to math and then you do the little.
Yeah, I think there's a root with like a, so you can put
You can
5,
put whatever root you
root
want.
button, yeah. Or you could just do 2 to the 1/5 power. Because that's all a 5th root is, right? Who thinks they have that? 5th root of 2, who's got that? Say again, sorry. 1.1.
486.
486, so I can round it to like 1.15, right? Approximately. And do the same thing with the 8, right?
And you
Yes.
put the, you put the line over it to say it keeps on going, or how would that work?
No, if there was a pattern, sure. But here I just rounded it.
Oh, yeah.
Because it's 1.148, blah, blah, I'm pretty sure it's not gonna be a pattern to that. No. Yes.
So for the one like plus 8, when you subtract it and you take the fifth root of it,
Yeah.
did you put the I in front?
No. Why not? What's the square root of -4?
2i?
2i. So you gotta bring complex numbers in to be able to do an even root of a negative number. What is the cube root of -8? What do I multiply
2i.
3 of? No. What's -2 times -2? 4.
Oh, so just
Times -2? So what's the cube root of -8? -2. Only even roots cannot handle negative inputs. Why the shit does that happen? Give me a negative number. -16. What is -16 squared? No, don't do it. Give me a smaller number. I want you to be able to do it in your head.
-2.
Good. All right, we just did it, but okay. Let's do -3. Ooh. What is -3 squared?
9.
It loses the negative, correct? So I cannot go backwards to get -3 then. -9 just can't happen. What is -3 cubed?
-27.
-27. So then I can go back from -27 to -3. I can go back. Cube roots, odd roots are laid back because they can be negative. So they can accept negative inputs. Even roots freak the shit out. We had to make up a whole new kind of number just to handle them, right? Or at least discover a kind of number. Let's say it that way. Can we stop for a minute? You guys understand that? Odd roots, completely cool with negatives. Even roots, can't handle it. Okay, maybe.
Okay, what about number 25?
25. Oh, okay, all right, we're getting there.
Okay.
Any other questions from homework?
Let me take a picture.
Sure. I'm taking moving pictures
I
too.
do sort of have a question, but it's not on this one, it's on 3.6, I guess.
Oh yeah, what you got? 3-6?
Yeah,
All right, this is the last question. 3-6. What you got?
it's like 24 and 30. I got this strange thing going on where, okay, so there's two ways to graph this, you know. It's like you can just sort of start out with the toolbox thing and you can just sort of work all the changes, or you can like make a table of X.
Yeah.
And when I do the table, I don't get the graph. I mean, I get a graph like that
Yeah.
when I do the table, but then I get the toolbox thing if I do it with the changes. And why is that?
All right, you ready?
Yes,
All right.
I guess so. I hope so.
Which one was that one you're just pointing at? Number 24?
Number 24.
Okay. So guys, this is 3.6. Yeah, number 24. What do you got? Okay. What input makes the output of this 0? What input would make this 0? Say again. -3. Does everybody see that? So the vertex, the turning point, has moved back 3. Notice how your last input you put was -3, so you didn't even get to see the turn. So watch this. Let's do this 2 ways, real quick. Can somebody help me with the 3 transformations that are happening here?
To the left 3.
Good, left 3. Careful, that's the last thing I do. right? Order operations.
You have a, translation across an axis.
Yeah, reflect across what axis?
X-axis.
Yes. Because the outputs will become the opposite, so it just flips over, right?
Yeah,
So remember, outside, up and down. Inside, left and right.
And then negative.
That's this. Yeah, the negative is this guy. Yeah. So left 3, reflect, up 4. What's the base function look like?
X.
Absolute value of x. So what's it look like?
It's the,
Like a V.
What letter?
The V.
A V, okay. Become a bit point. Okay. There's the base function. And then you just pick points and you move them, right? Okay. So I gotta go back 3, correct?
Yep.
So if I take this point, I go, become big. 1, 2, 3.
yeah.
Reflect, up 4. Jesus. 1, 2, 3. Okay, this should be enough. So back 3, reflect, up 1, 2, 3, 4. Back 3, reflect, doesn't go anywhere, up 4. See, for you guys, for me it's weird when you're right on the board. And then back 3, 1, 2, 3, reflect, up 1, 2, 3, 4. So now it's going to be here. Mike, real quick, do you see how you stopped here?
Yes.
So you never got to see the turn. Yes?
Why did you reflect after you left 3? Why doesn't the reflection
Technically, you could. In general, what I try to get students, if you follow order operations, you'll never make a mistake.
Oh,
The real truth is that's got to be last no matter what. You could do these either order, but if I just follow order operations, I don't have a new thing to memorize. I know order operations. So that first, then this, then that last. But Elena, you're right. You're right. It's just a way for me to get you guys to remember it easier. Just apply order operations, yeah. You guys semi with me? Now, real quick, if I make a table of values, and I use these inputs. Oh shit, -3 would be 0 plus 4. I know you guys can plug numbers in, I'm gonna do this quickly. -2 would be 1, -1 plus 4. -1 would be -2 plus 4. 0 would be -3 plus 4. 1 would be -4 plus 4, and 2 would be -5 plus 4. This looks like a straight line. In fact, it is this straight line.
Yes, it is.
But if you put in -4, -4 plus 3 is -1, absolute value is 1, -1 plus 4 is 3. It turned again. In fact, if I put it up here, it might be easier to see. If I put -4 here, and the output is 3, do you see how it turns at -3? Exactly what we see when we apply transformations.
It's
Yes.
exactly the same thing that happened in number 15.
Could be.
Yeah, because it did. I mean, like I'm drawing it, you know,
Yeah.
and here it is, and like all this time, it's a V shape, and it reflects, and it's like a mountain shape, but it gets over here, and I got nowhere to draw the other
Oh.
part. Because
By the
ran
way,
out
real
the
quick,
rest of the paper.
15, all these problems here, there's no graphing that you have to do. You don't have to graph these at all, right? Everybody help me out. I give you any function at all, how do you find the x-intercept? Any function at all, how do you find the x-intercept?
Solve for y.
0.
Make
Make f of x equals 0.
make y 0, and how do I find the y-intercept?
Plug in the x value.
Make x 0, right? Eternally. The last math course I took, I had an equation that had like 12 variables in it. How did I find the w-intercept? I made all the other letters 0. I don't care what level of math you're at. How do you find the whatever intercept, how many dimensions you live in? Make all the other letters 0. You guys kind of with me? No graphing needed for this one. This one you just make x 0 and solve, and then you make y 0 and solve. Now, real quick, how many x-intercepts could an absolute value have? It could have 1. It could very easily have 2. Or it could have none, right? There's no x-intercepts if it's like this. You with me? You guys with me? So the x-intercept situation could be none or 1 or 2 x-intercept. Okay. And again, at this point, if I make this 0, you all should be able to solve this equation. Remember the two cases that have to come up, right? You guys with me? Okay. All right.
All you really have to do is plug in x values and get the y value. Like, starting from -3 to.
No, for this problem?
Oh,
No, this one specifically wants the intercepts.
oh, the intercept.
What makes the x-intercept? Y equals 0. What makes the y-intercept? X equals 0. So you're very specific on this problem. No graphing
So there's
required.
0.
Huh?
There's a 0. So we're just plugging in 0.
Yes. One at a time. Let x equal 0, that's a y-intercept. Let y equal 0, that gets to the x-intercept. Yeah.
2.6?
Yes. Is it? Wait.
3.6.
3.6. Yeah.
How do you cancel like an absolute value?
I'm sorry?
How do you like cancel an absolute value?
Oh, okay. There is no canceling out you guys. So, let's do this. I don't know if I've done my little rant about absolute value. I do not like the fact that we created the absolute value because it's kind of subversive. It's two functions in one. So for a normal single function like x cubed equals 8, I can cancel the cube, correct? For two reasons. The cube is a nice single function and it's got an inverse, yeah? So I can cube root both sides and be done with it. Yeah. When I have this, there is no inverse of absolute value. There is no, because what's the absolute value do? Two different things, right? So I have to do something a little more, I don't know, I always think of it as being kind of sneaky. I don't cancel the absolute value. What are the two things that this number could be so the absolute value is 11?
17.
No, not what x can be, what this number can be.
It has to be 11.
Yeah, it can either be 11, because the absolute value of 11 is 11, or
Negative 11.
that number could be negative 11, because then the absolute value of negative 11 is 11. Everybody see that? Does everybody see that? I mean, it's very direct. You're not used to this. You're not used to being able to look at a problem and go, well, what would that piece be? That's exactly how we do this, because absolute value sucks. Absolute value is not a function. It is two functions. Right? Does the absolute value do one thing to any input? No. It does two things. Do you guys understand? What's the absolute value of 5?
5.
It did nothing, correct? Careful. Absolute value is always positive because it's based on distance. What's the absolute value of negative 5? It changed the sign. So do you see how it does two different things depending on what the input is? All right, I love it. You would, Jeff? Okay. Is that right? So that's a good question. That's why we can't kill it directly, because it's not really one function, it's two.
So you have to plug a number in, like always, to find it.
No, I'm not going to plug a number in. I see what you mean, though. I think, what could this be? It could be 11 or negative 11. So what's the shortcut? Make what's inside equal to this, and also make what inside equal to negative that. And then solve, right? So then I do catch up with what you guys were saying earlier, 17 and negative 5. Okay, maybe. Anything else from homework stuff? All right, let's get into finishing up section 2.6. That's all I wanted to say. Oh. So the other things that are in 2.6, for example, if I had this, x to the 3/4 equals 8. How do I solve that?
Just split 8 into 4, and then get the third one.
No. This does not say 8 to the 3/4. This says some number to the 3/4 equals 8.
You put
X
X
to the
third
1/4.
power and then cube and then fourth it.
Negative
Yeah,
third
so like how would you solve this?
2, and then you put a.
How would you solve it? Don't tell me, I don't care what the solution is. Yeah.
Cube
I would take a cube root. Isn't the cube root a 1/3 power?
Yeah.
Wouldn't these cancel each other? So you're always trying to kill the thing that's there. Why can't I tell what X is? Because there's shit in the way. So how do I kill 3/4? What power would kill it?
4.
4/3. That would kill it. Do you guys see that? There's another way that radical notation messes us up. If we just always kept it fractions, this would be like automatic. But radical notation, we think of it differently, and now we got, oh God, that's different. No, it's the same. It's just silly notation. How the shit do I do this? What's the root?
3,
Good. Cube root of 8, and what's the power?
4.
4.
Fourth power. Okay, what's the cube root of 8?
2.
2 to the fourth power?
16.
16. Alright.
Wait, how did you get that?
Get which one? Sorry.
The cube root of 80
Oh, this, okay, again.
I mean,
Fractional powers are roots. So there's a 1/3 power here, right? And there's a fourth power here, correct? So the bottom is the root,
yeah.
just like on most plants, right? And one semester I did have a future botanist that was like, well, actually, Jeff, tubers are roots. Oh, no, most, and look at me again, nerd making fun of another nerd. The roots are on the bottom,
Okay.
powers on the top, because powers are powerful. Yeah. And then you just attack it. And again, we're not brought up with fractional power, so when I write it like a root, you guys can figure out the answer quicker, because that's more like what you're used to. Okay, maybe, is that all right? So for example, if I had, what do you got, Jeff? 27 to the negative 4/3 power. Oh boy.
Then you flip it.
Good, first thing I would do is flip the damn thing. By the way, 4/3 is negative. Is 4/3 being raised to a negative power?
Being lowered.
Is 4/3 being raised to a negative power? 4/3 is the negative, yes?
Yes.
So negative 4/3 does not equal 3/4. You don't flip that. That doesn't make any sense. What number is being raised to a negative power? What number is being raised to a negative power here?
4.
4 is the negative. What number is being raised to a negative power?
The 27.
27. So it's the thing that flips. You guys kind of with me? So I get a lot of people that tell me this is 27 to the 3/4. Some of you guys might be sitting there saying, what's wrong with that? Or some of you guys, can you see where that came from? I didn't flip the correct thing. The negative power is on the 27. That's what flips. Okay, maybe. Just showing you a very common mistake, and it's understandable. Good. Now, how do I do this? What's the root?
3.
Cube root. What's the power?
4.
Fourth power. Cube root of 27 is
3,
3. 3 to the fourth power.
81.
Yeah. Kick ass. Is that all right? You guys all right? You guys seem shell shocked. I'm sorry. Okay. All right. This is a Tuesday after a long weekend. It's always weird. You wake up and you're like, oh yeah, it's cool. That's what I do. I'm like, oh yeah. Okay. Yes.
So the 1 over the 27 to the power, or that 1 comes from the fact that you're switching the 27. That's what you're.
Yeah. So think of it like this. Isn't everything over 1?
Right.
We don't normally write that because we don't normally need it. But now, if it's to a negative power, it just wants to go to the other side.
Okay.
Yeah. And what will be left up here is the other one that we normally don't write. Isn't there always a one-time stuff?
Yeah.
So when this moves down, that one is left up top. That's now happy. Yeah, and that seems silly, but that's another way to think of this. If the power is negative, the thing doesn't like where it is. Move it to the other side.
That's why you have the Death Star. Because the numbers want to go to the dark side.
Oh, whatever works.
Yeah,
Okay.
on the video.
So real quick, what if I had this? Everything's thirds. I don't care. What's the very first step I can do here?
Flip it,
Meaning.
8 goes to the top.
Yeah. And then the key root of 8, 2, yay, blah, blah, blah. Okay. So wherever the hell the negative power is, it wants to be on the other side. Dark or light side, yeah.
So it would just be 8 times 1/3.
No.
8 or 8 to the 1.
8 to the 1/3 power, yes. I like it. Yes.
So why do you have to switch it if it's like to the negative power?
That's what, do you have to? No. Sort of like if I get this answer, is that correct? It could be, but it's just not reduced. So we don't leave things with negative powers normally because it's one extra thing that hasn't been done yet. Negative power means flip. You guys with me? So if you tell me the answer is square root of 16, you might be technically correct, but why would you lose a point maybe? Because you could do the square root of 16, right? So if you tell me the answer is 2 to the negative 1, well, you could flip it. So we always do all the stuff we can do. So we don't leave negative powers. I like it. Is that all right?
I'm just confused, like why,
Why is it negative being
how is it
flipped?
correct that you can just flip it?
Oh! Alright, alright, you ready? Alright, let me see if I can do it with this one. Okay. Guys. You never have to do this, ever.
No.
I know, I'm gonna do it a different way. You never have to do what I'm about to do, but it's an explanation, right? If I multiply top and bottom by 8 to the 1/3, I get 8 to the 1/3 on top, yes? Does anyone know what I get on the bottom? Are the bases the same?
8 to the negative 1/9, right?
Yes, that's.
Hell no. Bases are the same, what do I do with the powers? What's x squared times x cubed?
You cancel out?
Yeah, I add them, correct? Because they're always one step too far. So when I have the same base and I'm multiplying, I add the powers. What's negative 1/3 plus 1/3?
0 or 1? Or
0?
0?
0. And what's 8 to the 0?
1?
So flipping this to the top is a shortcut. I skip all this shit and just get to the actual idea. Negative power means flip. Does it make sense?
And the reason you multiply by like a positive
Bless you.
is to cancel it out, right?
Yeah, I want the power to be positive, so I cancel out the negative part and it shows up top. I do the same thing if I turned it around, right? Yeah. Okay. But just remember, you never have to do this ever. Everybody understand? I always get somebody come up and say, "Why do you make this so hard?" No, don't do this shit. Negative power means flip. Wherever it is, it wants to go to the other side. Okay. All right. What else was in this section that we talked about? Wait, this is the wrong section. Is this 2.6? 3.6, okay. Got it. There was one more page. Blah, 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 blah. Okay. Yeah, okay, so now we got radical stuff. Let's see. Somebody tell me, if I square root a number, can I get a negative output? No. Good. So that's gonna come up in a bit. So does this problem say square root equals negative? No. Rice positive 2, okay, good. How do I solve this?
Square both sides.
Yeah, so always, I don't care what the hell the equation is, we're thinking opposite function, right? Do the opposite to start to solve it. If I square both sides, that kills that. And again, the square root has got my x stuck. My x is stuck in the square root, so of course I want to kill that, I want to tear down that wall. Mr. Gorbachev. Okay, and then I get x minus 4 equals 4. Holy shit. So I get x and say, okay, that's easy, right?
Yeah.
That's a nice one. That's a nice one, Jeff. All right. Here, this is just one step up from that. Can you guys solve that one for me? What is it, Jeff? Sure. No tricks. Just go ahead and solve that. Oh, yeah.
You take away the radical, 4 minus 3x. I'm sorry.
That's right. So of course, what do I do to both sides? Square both sides. So I can free up where my variable is. Right. So I get 4 minus 3x equals 9. And now this should be, right? So subtract 4 if you want to. How was it, John? Negative 5/3, you get a fraction, who cares because you're done, right? You can check it like always. So very quickly, could somebody give me a very simple equation with a radical in it that has no solution? Based on what I just said a minute ago.
-3.
Yeah, if I just take the same equation and I set equal to -3, why will that not have a solution? Because like you just told me a minute ago, square roots always come out positive. Or complex, right? They cannot come out to be a negative real number. They can't. Yes?
How would that not work though?
Well, unless we.
Now, real quick.
Unless we put I.
Real quick. No. I won't do shit for us. The square root of a negative number is some kind of imaginary number, correct?
Yeah.
The square root of nothing is negative. Square root's always positive. You stop for a minute. By the way, why the shit is that? All right, real quick. How many things do you square to get 9?
2.
2 things. The square root of 9 and the negative square root of 9. You guys with me? Weird way to write it, correct? But 3 and -3. Is everybody with me?
Yeah.
The square root symbol then is the positive root. If I want the negative root, I have to put a negative there. So there's no way in hell that equation can work. Now, the weird thing is, I think somebody just said something I was about to lead into. I could solve it. I'll get the wrong answer. How do I solve it? I'll solve it the same way. So right here, you notice, no solution, don't do shit. If you do shit, you're going to think there's an answer, but there isn't. So watch. If I square both sides, what happens?
9.
Yeah, this cancels, right? And I get 9, and it looks like I get the exact same answer as before, yes?
Yes.
If I try to plug it in, 4 minus 3 times -5/3, that would be 4 plus 5. Is that cool? The 3's cancel, the negatives cancel. 4 plus 5 is 9. What's the square root of 9? 3, not -3. So that doesn't work. The only solution that could work doesn't. But you didn't have to do any work. From the very beginning, you should notice it's bogus. I'll go this way. What's up?
So what you're saying is a square root cannot equal a negative?
Yes.
Okay.
I was gonna ask if you had like a number, let's say plus 5 outside the root, then you would have a solution, right? So it was.
Oh!
square root of x.
Yeah, if the, okay. So next level. I like, Anna's like, let me help you move on, Jeff. All right. The next level problem would be this kind of problem. And we've seen this kind of thing before with absolute values. Yeah, so many parts of mathematical solving equations are first isolating where your variable is. So this specific problem, I like to pretend like I'm teaching you guys how to be a good tyrant. If you have a country and you're a tyrant, right? Unfortunately, there's a lot of examples of that recently here. But I would isolate the radical element and then I would kill it, right? Another way to say that less, horribly, is get the radical by itself and cancel it, correct? But I'm gonna isolate the radical element because then I can kill it. Real quick, guys. Here's the biggest mistake I see. People square each piece of this. Okay, no. If I square one side, don't I have to square the other side? And how would you square this? Wouldn't you have to FOIL it?
Yeah,
Wouldn't you still have a radical in the middle term?
yeah.
Shit! No, so what do I do then? I want to kill the radical, so I get it by itself first. Add 4, 11. Yeah. So then I get square root of x minus 1 equals 1. So again, we've seen this with absolute values. Don't just stop because that's negative. Get the radical by itself. Oh shit, this is going to be fine, right? It's going to have answers. So then I can do it. Now I can square because that will directly kill that guy. X minus 1 is 1, so x equals 2. Crazy sauce. Okay. So if you simplify and you get radical equals negative, stop. No solution. Will the algebra give you an answer? Yes, but I want you to notice, right here when we did the work, didn't I lose the negative? So the math goes, okay, sure. There's the answer if that was positive 3, because the math doesn't know. I need you to see it. When we squared, didn't we make the negative go away? So math only knows what we've got sitting here at the moment. So it says, okay, there's an answer to this, but it doesn't work if that's a negative. It doesn't, there's no way it could know. I really want that to make, because as a student, I would imagine that if you do a problem, you get an answer, and you did everything right, but there's no solution, you might be a little like, what the shit? It's not math's fault. We did something bogus. We lost the negative. Yes? Which one? Sorry? Oh yeah, we're getting there. I always build. So one thing we haven't seen yet is a variable that's also outside of the radical. It's like I placed you guys here. I love it. So what would I do with a problem like Maria? No, like this. Thank you. Oh, I gotta make one that works. That might be, you want one that works? Probably, okay. No? Okay. I can make a lot of those. Let's see. I'll go ahead and make it work just to be different. Oh, that'll, sure. You can do it, Jeff. Let's see. Let's do, yeah, let's do that. Okay. No, that's gross. All right, let's do that. All right, that looks funky. I like that. I'm trying to make it come out like a decent answer instead of something really funky.
So we still square both sides.
Yeah, the nice thing is the radical's already by itself,
We got FOIL.
so I can directly attack it, right?
Oh.
So I square both sides. Now the weird thing that happens here is I get a bunch of people telling me that's 4x squared plus 9.
No, it's got a bunch of junk in the middle.
It's got a bunch of junk in the middle, right? You gotta write that sucker twice and do like, maybe back here, Philip said you gotta FOIL that sucker. You with me? You guys kinda with me. So I'll do this side. Yay. I did half the work. This side, it is not 4x squared plus 9. You can see why somebody would think that, right? But squares don't distribute across subtraction. You have to write this thing twice. Right? So then you get 2x plus 3 equals?
4x squared minus 4.
Yeah, minus 6 minus 6 minus 12. I like it. What are you saying again, sir?
-6, -6.
Good.
Minus 12x plus 9.
Plus 9, there it is. Not surprisingly, When there's an x inside and an x outside, the equation becomes worse. How do I solve this shit?
Yeah, minus the, both 2x and 3 make it equal 0.
Good, I want to get it equal to 0. Why? Because there's a term with a variable being raised to a power that's not 1. You guys with me?
Yes.
That is your trigger, right? When I see that, I get it equal to 0 and then factor it. So if I subtract 2x and subtract 3, I get that.
Now we do a quadratic equation.
No.
You're gonna factor out of 2.
Yes. First thing I would do is divide by 2.
Divided by 2, yeah.
That's going to factor.
0 divided by 2 is 0.
You got it. That's going to factor. How do you factor that?
Quadratic equation?
Good. 2 times 3.
Oh, yeah.
Let me pull it up here.
It's
2 times 3 is 6. It's crazy. Factors of 6 that add to be negative
minus 6
7.
plus 1.
Negative
1,
-1,
-6, negative 7, right? So again, this is going to happen the whole semester. We're going to learn new stuff. The first part of the problem is going to be brand new stuff, and then the rest of the problem is going to be old stuff. So I think part of the reason students make mistakes is you don't realize, oh, old shit can come back. And let the old shit be old shit. Let that be easy. So very often the first few steps are going to be brand new stuff, and then we're going to have old stuff. And people think, oh, everything's new in chapter whatever. No. Yeah.
Why did you divide it into 2?
Just to make the numbers nicer. And because I can. Right? Yes.
No.
I got an equation, so I can divide by whatever I want to except 0. 2 will help me.
You could have also just put the 2 next to the.
Totally. But I
Same
didn't
thing.
need it at all.
It's the same thing though, right?
Totally. All right, so what's the next step here?
Wait, isn't it? Didn't it just go
6x.
like, if I step it out, it goes 2x squared
Yeah.
minus 6x
Sure, if you want to.
minus x or 1x plus 3.
Okay, sure. What comes out of these two?
2
And?
And x.
and x, yeah.
Right? What's left?
X minus 3.
X minus 3.
And then.
Real quick. Sorry, Phil. Are these the same?
No.
Good. What can come out of here?
-1.
Good. You gotta
minus.
change the signs. These are not the same, correct? And they need to be the same.
So a minus.
So if I take a -1 out, that becomes positive, that becomes
Negative.
negative. Are these the same now?
Yes.
Yes. Okay.
But why did it become a negative?
I'm taking a -1 out, right? So if I divide by negative, don't the signs change?
Oh.
Yeah. So now these are the same, so then I can do this. And then I can solve each piece. Is that cool? Right, either x minus 3 is 0, or 2x minus 1 is 0. And then, yeah.
Would you find if you just factor it from the 4x squared?
Totally, yeah. It just is a little worse, right? Because then you'll get 24, factors that add to be 14. So whenever you can divide by a number, do it, because it's going to reduce the numbers, make everything easier, right? But is it wrong if you don't? No. Just easier if you do. So what do I get? I get x is 3, or x is 1/2, is that cool? Now here's the trick. Here's the thing. Is that cool? You guys with me? It's supposed to be 2. These don't both have to work. What kind of number is 2x minus 3? Is it negative or positive? 2x minus 3. Is that negative or positive?
We don't know.
We do not know. If x is 0, what kind of number is that? If x is 0, this is a negative number, correct? If x is 5, what kind of number is this? So we do not know. Are you with me? I need you to understand. So if this is a negative number, I know there's no answer, I can stop, but I don't know. So when I get two possible answers, I have to go and make sure they actually work in the original problem. What happens when I put a 1/2 in here?
I mean, 1 minus 3.
So the original problem was square root of 2x plus 3 equals 2x minus 3, right? When I put a 1/2 in here, what happens? That's a negative number. Would that have a solution? Square root equals negative? No. So when I try to do this, when I try to put a 1/2 in, I'll get square root of 2 times 1/2 plus 3 equals 2 times 1/2 minus 3. I get square root of 1 plus 3 is 4. Is that equal to 1 minus 3 negative 2? Is that true?
No?
Nope. Not an answer. Get out of here. But if I plug in 3, I'll get 3 times 2 is 6 plus 3 is 9. 2 times 3 is 6 minus 3 is 3. Oh, and square root of 9 is 3. It'll work. Okay, maybe. So again, as a student, I would be surprised if you weren't upset that you do all the right work and one of your answers is wrong. Do you agree with me? It's not wrong in the sense that you did the problem wrong. It's wrong because I can pick up what's called extraneous solutions. Because what's the very first damn thing we did? We squared it. When do I know there's no solution if this number's negative? But when I square it, don't I lose the negative? So then math says, oh yeah, there's an answer to this new equation you made, but I have no idea if it works in the original equation. I gotta check it. Okay, maybe. You see what I mean? So I really want to address that, because as a student, math sort of sucks in the first place, and then you're like, oh, I did everything right, and I still get an answer wrong. No, that's part of the process. That's just the trade-off to be able to solve this damn thing at all. Is sometimes we get more answers than we're supposed to. So what's the short of this? When you're solving radical equations, check your solutions, because sometimes they won't work, right? You guys kind of with me? No, Jeff. Okay, yes.
When that happens in the homework, you want us to like cross out the answer and show that we know it doesn't work.
Do it again, sorry?
Like when it shows up in the homework and you check everything, you can just cross out the.
Yeah, totally. So just do exactly what I just did. Right? I need to see both possible answers and then check them and throw out any that don't work. Is it possible to get an equation that has no solution? Of course, we saw that earlier. Right? Okay. One more idea for today. That pretty much finishes section 2.6. You just got to get in there and try that out. You see this whole section here with all the radical stuff. Okay. All right. So the last idea for the day. It's kind of a big idea. And it's something we've been using already. So, how do I solve any, this is going to be a great question. How do I solve any equation? At some point, I'm going to have to do something to both sides that kills something. Very often, correct? So that's what we call the inverse function. An inverse function is one that does the opposite of the original function. So a very simple example. If my function is x plus 2, what does that function do to any number?
Raise it by 2.
Adds 2 to it. I'm not talking graphically, just computationally. If I put a number in, it adds 2, correct? So what's the inverse function?
Take away 2?
Yeah, x minus 2. So on that level, it's just a function that has the opposite operations, but also in opposite order. So this was easy, because how many operations are there? One. So of course this is easy. Easy as shit, all right? What's the opposite of adding? Subtract. That's crazy. You with me? Okay, maybe. The symbol we use for inverse is an unfortunate symbol. It's a very bad symbol. And again, either we were drunk the day that we made it, or we weren't drunk enough. One of those two things. Because trust me, there's a lot of drinking in math history. The symbol we use for inverse looks like this. That is very unfortunate, because what's a negative power mean? It means you flip it. But when it's on a function, it's understood to be the inverse function. So very quickly, huh?
That just means that.
Yeah, this symbol is one symbol. It just means the opposite of the f function, the inverse of the f function. If I wanted to flip this, if I wanted to make it this, I would have to do that. That means flip the f dude, right? Which actually, that phrase means entirely something else. In general, don't flip the f dude too long. Okay. But here, this would mean flip the function, right? You guys kind of, do you see that? It's just an unfortunate notation choice made in history that we're stuck with. Damn it. Sort of like,
It's a rule.
huh?
One of those rules.
No, it's just a definition. It's not even a rule. It's just a definition. We could have made the symbol any damn thing we wanted to, but we chose this. Oh, well. Okay. So, what if the function is more complicated? What can I do? Well, let's build up to that. Let's do graphically first. Yeah. So this is the basic idea of an inverse function. It's just exactly what we think. It's the opposite. So we've already used inverse. How do I solve the cube root of x equals 2? I cube both sides. I do the opposite function. So when do I know an inverse function exists? So let me ask you this. If I have the cube root of x, what do I get when I put an 8 in there?
2.
I get a 2. That's crazy. What's the inverse function?
Negative.
No. What's the opposite of cube rooting something?
2 cubed is 8.
X cubed. So if I think backwards, and of course it makes sense I'm going to think backwards because the inverse function does the opposite. So the inverse function would take the output of this guy, and what's it do to it? What's 2 cubed?
8.
Holy shit. So the inverse function takes the output of the first dude and brings it back to what it was. It undoes the other function. Yeah, so what's funny about that is, if I had a whole list of xy's, what could I just do directly to the table to make it for the inverse? Just flip the damn things, right? Switch the x and the y, are you with me? So, for example.
27.
What? Okay.
So 27 in there.
27, okay.
X, and then x equals 3.
You got it, it's crazy. So let's say I'm given, real quick, if I'm given this table for f, I really want to make sure you guys see this. Okay, what would the inverse function table look like?
Opposite.
Yeah,
Just flip them.
just flip it.
3, negative 1.
Yeah, so it'll be 3, negative 1,
2, 0.
2, 0,
3, 1.
negative 3, 1.
And negative 5.
Okay, so everybody get that by itself.
Uh-huh.
Holy shit. Why can't everything be as easy as that? Because not everything's freaking inverses, right? So, yes,
What is that function?
say again.
What is
Oh, okay, I don't know, just making up some shit. So again, does this necessarily have a algebraic representation? I don't know. Why is this a function though? Why is this a function? Why is this a function?
Every input.
Every input has
One out.
one output. Why is this a function? Every input has one output. Are you guys with me? So watch this. What if I added one more point? Okay, I like it. Is this still a function?
No.
Come on now, you're better. Come on. Is there any input
Yeah, because then it's
that has more than one output?
Yeah,
Which input has more than one output?
Why?
No. Which input
0 and 3.
has more than one output?
Oh, no.
-1 only has one output. 0 has only one blah, 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 blah. Yes?
Yes.
Now, when I try to make the inverse, what happens? What's the extra thing I gotta put down?
2 has,
If I put this flipped, you with me?
yeah.
Is that a function?
No,
Yes.
no.
Is there an input that has more than one output? What's the output for 2?
0 or 3.
0 or 3. Is that a function?
No.
No! Good, okay, good. Let me stop for a minute.
Vertical line turns horizontal line.
We're getting there. Yeah. It's funny how I try to build. It's crazy. Okay. Let me stop for a minute. Before I did that, everything's beautiful.
Yeah.
So there's got to be kind of like an easier test to see if something is what's called invertible. So we're going to get there. I'm going to build my way up, but just want to throw that out. Not every function has an inverse. You can't always go backwards.
It has to be 1 to 1.
Yeah, we're getting there. Okay.
Okay.
So, if I give you this graph, let's see. What you gonna check? Okay, let's do here, 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 here. Okay, is that a function?
Yes.
Yes.
Now, let's blindly just, so that, I'm gonna call that the G function.
Yay.
I should put that in blue, because that's in blue, Jeff. That's amazing. So the blue is the G function. Can somebody help me graph the inverse function? What points does the G function go through?
-2, -3.
Yeah, -2, -3.
3, 3.
0, -1.
0, -1.
1, 2,
1, 2,
and 3.
3, 3. So what points will the inverse function go through?
Negative
-3, -2.
Let me catch up. So -3, -2, -1, 0,
1, 2, 1.
2, 1, 3, 3.
The opposite.
Yeah, right, we already talked about that. It makes sense. You just flip them, right? The input of one is the output of the other one, vice versa. Because they undo each other. So if I plot those points, -3, -2, where am I at? -1, 0, 2, 1, 3, 3. First off, I get a very nifty freaking picture. I don't know if you guys agree with me. I always think about Nazca lines. Has anybody ever heard of the Nazca lines in Peru? Look them up, kids. They're neat. There's things that ancient people did that only make sense if you're way up in the air and you look down on them. So there's like a big spider one, and there's all these things, all these shapes that they kind of made on the ground, but they only make sense if you're way up in the air. So it's still,
Called what?
there's a theory that they had balloon technology, but we don't know.
They're
We have
called
no
what?
idea. Or it's the aliens that came down and helped, you know.
What did you call them?
Huh?
What did you call them?
Nazca lines. See if I remember how to spell it. I think it's that Nazca lines
Oh,
in Peru.
If it's not Google, we'll know what you're talking about.
So again,
If it's not spelled that way, Google will know what
yeah,
you're talking
Google is great. It'll go, I'll help you out, human. Yes.
Do you see it a lot like at farms and stuff?
Oh, like the you're thinking about like crop circles.
Yeah, maybe.
Yeah, but you're right. They make these funky. Yeah.
Yeah.
Exactly. There's a lot of nice symmetry. Can somebody help me out? We talked about, remember with parabolas, there's a line that was like the symmetry. Where's the line of symmetry here?
about. It's right,
Isn't it diagonal?
yeah, across.
It's exactly. Who knows what line this is?
Y is equal to X.
Yeah, this is the y equals x line. Why does it make sense that it flips across the y equals x line? Because we switched x and y. So the inverse function will always flip across this mirror, across the y equals x line. Therefore, by the way, is the blue line a function?
Yeah.
Is the black line a function?
Yeah.
Yes, totally. Can you guys see that if I had a function like a parabola? So is this a function? Yep.
Yeah.
Can you guys very quickly tell? Can you guys draw it in the air if I invert this? Yeah. It's gonna do this thing. So the inverse would look like this, basically. Is that a function? No. So how do I tell if a function will have an inverse? Instead of, how did you guys know this was not a function? Doesn't pass a vertical line test. So instead of flipping it and then doing a vertical line test, we just flip the test. We do a horizontal line test.
A 1-to-1.
That'll make it 1-to-1 if it passes the horizontal. So I really want it to make sense. It's the same stupid test, vertical line test. We just flip the test instead of flipping the function. It's a lot easier to flip the test. Yes? So is this invertible? Is that a function?
No.
No.
Is that a
That
function?
one's a function, yes.
Well, yeah, it is.
Yes.
The inverse is not.
What time is it? Oh, they really want to get in here. That's a function all day, yes?
It's a function,
Is it invertible?
no.
No, because it does not pass the horizontal line test. All you need is one horizontal line that goes through more than once, just like the vertical line test.
So if 2 points in the horizontal line test are there, then
Yeah, all it takes is one little turning on itself, right? So last thing, guys. I don't end my class based on when somebody tries to get in. I end it based on the time. I love you guys. Last thing for today, and the last 5 minutes, okay. You're all like, come on, Jeff, shut up. If I give you a graph, do you guys agree with me? If I give you a graph, it's easy as shit to graph the inverse. And you can tell if it's got an inverse or not. Very simple. What if I give you a function like we did at first, but more than just x plus 2? What if I give you this, and I want you to find the inverse?
You put 2x over 7 and 3 over 7.
You make it x equals, and then you put the y into the.
So here's the trick. How do I graph the inverse? What's the very first thing I do? I get all the x, y's, and I switch the x and y, correct? This is the beautiful thing about inverses. Switch the x and y to get the graph, switch the x and y to figure out what the inverse is. So where's my y?
After that,
Good. Bring the y back. Now, you're not going to see this in the book, but I do this. Because I'm about to do something that is not algebraic. I'm not going to do something to both sides. I'm going to do something that is a process. I'm going to switch the x and y. So I always draw a little dotted line. It's got a habit, so I'm just going to do it. So what does that dotted line tell me? I just applied an idea. I didn't do something algebraic. Are you guys with me? I need you guys to understand. I didn't just do something to both sides to make it this. I switched the x and y because I want to find the inverse, right?
yeah,
Now I solve for y. Remind me, what's the inverse function again? It's supposed to do
Opposite.
all the opposite shit, yes?
Cancel each other.
Notice as I try to solve this for y, am I not going to be applying all the opposite operations? What's the very first thing I do? What sucks about this?
Multiply by 7.
I'm going to multiply by 7, so it's not a freaking fraction anymore, right? It was divided by 7, now it's multiplied by 7. And then I
Add 3.
add 3, it was subtracting 3, now it's adding 3.
Divide
And then
by-
I
divide by 2.
divide by 2. It was multiplied by 2, now it's dividing by 2. So this is our inverse function. So we would write
7x plus 3.
f inverse of x equals 7x plus 3 divided by 2. So it did divide by 7, now it multiplies it at, subtracted 3, now it's adding, it multiplied by 2, now it's dividing. Perfect. I love you, you're all like, the last 3 minutes you'll like agree with whatever the hell I say, okay? I totally get it, Mr. Wall, totally get it. That's fine, that's fine. Get at it, go on. Oh, Elena, Marsa, Maria, Diaz, Elena. Oh. You're good. Elena. Dahlia. Asia, Landon, Aaron, Raul. Come on. Hey. That's it, guys. Definitely haven't graded all that homework. Everything right there.
I have one question. So, for that test, where do we end?
Yes. Ended at 3.5.
Mr. Waller,
Yeah.
what is the wire on this?
Oh yeah. Where did it come from? There's a bunch of things that add to be -5x, right? A bunch of things add to be -5x. Why specifically those? So just show me real quick.
How do you want to show us?
Well, how did you do it? Where did it come from? What'd your brain do?
It's like multiply
Multiply what? 3 and 8 to get 24 because 2 times 12 is 24. All right, show me that step. Yeah, right. Does it make sense?
Yeah.
Okay, good. You're welcome. Were you here for the? Yeah. I missed everything because I got way worse. I went to the repair, gave me some antibiotics, gave me some other stuff. It's getting better, but I have, well, they said they weren't able to like, so I have to make an appointment with ophthalmology, and I did, and it's like next week, so by the time I get to see them, it might be healed. We'll see. Anyway, so like the whole day, it just got worse and worse, like the pain. Anyway, so I missed out on. Feel bad.
Well, it was nice, I looked at the setup in the back of the theater, and the music department, you know,
No way.
cello was
Really?
there, a violinist,
It's cool.
yeah, so they had music playing, and then they had to stop it to allow for like speeches, all the digitans were there.
Is this
It's
me?
good.
Jesus.